Okay, we're continuing in this lesson with continuous random variables and the probability density function, D for density, probability density functions that are appropriate for us to be studying when we look at continuous random variables. Now, all right, so we've got one on the screen and it's sine x over 2. That's our our probability density function right here, defined across 0 to pi. So what we're going to do first is we're going to sketch it. Okay, that's a nice little bit of practice for us, a sine curve that's going here between 0 and pi. So we know what the sine wave looks like so, between 0 and 2 pi. We're only going to pi, so we've only got half of the above x-axis section. Now the over 2, that's got a vertical compression effect. So where sine x would normally run from 0 to 1 here, the effect of the half is to compress by a half. So this is our sketch. Now if this is a valid PDF, then my integral, my area here, should equal 1 if this is a valid probability density function. So we are going to test that by evaluating between pi and 0 of f of x equals sine x over 2. Okay, so in effect we're doing a half sine x dx. Okay, so we can say that, well, that's a half sine x goes to cos x, or negative cos x, on integration between pi and 0. So it's minus a half cos pi minus cos 0, which is negative a half. So cos pi is equal to negative 1, cos 0 is equal to 1. So we end up with minus a half by negative 2, which equals 1. So we have ourselves a valid probability density function here. Okay, so good start. Our area is 1, so this can be used as a probability density function for a random variable x. So now to find the mean and the mode and the median, we are going to apply what we know. So the mean, well, the mean is, because this is a symmetrical function, actually the mean is going to be sat, because it's symmetrical, the mean will be sat here. Now, because it's symmetrical also, I know that, and the total area is 1, I have 0.5 in each half. So I know that the median will be equal to pi on 2. My mode is the highest value, so the value of x that gives me my highest function value, my greatest function value. So that's also pi on 2, and my mean is pi on 2. Now we can find the mean, remember, by calculating x sine x over 2 between pi and 0. And this, well, in order to evaluate that, we would need to bring in our calculator, which, I'll go in here, and we're going to do a bit of calculator work in this lesson. So we're going to be doing some integration. So we would integrate between 0 here and pi. Wow, I think this is really hard to use with a stylus. In here, I'm going to pause. Okay, so I need to put my function in here. It's really hard. Okay, finally got there. So just entered into the calculator, evaluating between pi and 0, x sine x on 2. You can see we get pi on 2. So going back, right, so we have our mean, mode, and median for that function. Okay, I'm going to bring up another example. Okay, we're going to look at an example here where the calculator is going to be important for us. So let's have a look. A continuous random variable has this PDF here, between 1 and 3, and a is a constant. All right, we want to find this value of a. All right, so in order to do that, then this value, what is going to be required is that between 1 and 3, that a over x squared minus 4x dx, that's going to have to equal to 1. So we're going to need to solve this. We're going to need to solve this this equation. All right, now this is a GDC challenge because we don't have the means. Well, we probably do actually. We could make partial fractions here perhaps and solve this. However, we're going to look at how the calculator does it very quickly for us. So let's head over to the calculator. All right, so in menu, I don't use this a lot, menu 3.1, we've got a solving mechanism. So we're going to solve, and I'm going to pause while I pump this in. Okay, I just went and found our calculator rather than the VCE calculator, the CAS that we were using before. So, okay, now what we're going to, if we remember what we're solving, it's this equation here on the screen. I want to find out what value of A gives me an area of 1. So I need to find out the value of A that makes this a valid PDF. All right, so into the GDC we go, and I open up a menu 3.1, which takes me to solve. I open up an integral, and I'm going to go between 1 and 3, and open up a fraction. Okay, now I'm going to put an a in here. That's what I'm solving for. And underneath here, I've got x squared minus 4x in the denominator. I'm integrating with respect to x. Now I need to tab across, hit equals 1. I'm solving that equals 1, but I need to hit comma a to let this machine know that I want to solve for a. I hit enter, and there's my value. So there's my value of a. A equals negative 1.82 to 3 significant figures. Negative 1.82. So we go in here and say, right, therefore, a is equal to negative 1.82 to 3 sig figs. That value of a gives me a function that has an area of 1 between 1 and 3. Okay, so now I want to find the expected value of x. Now the expected value of x is going to be, between 1 and 3, it's going to be a by x over x squared minus 4x. Remembering that the expected value is, in general, x fx between the values. All right, so I want to evaluate that for my expected value. So I now need to take my value of a here, and I'm going to store it like so. So I hit Control Store, and I'm going to store that last answer as my a value. That doesn't seem to have worked. Store as my a value. Right, so I store the value like so. I've now stored my answer, this answer, in the variable a. So I now hit enter, and I now want to evaluate my integral between 1 and 3, and I'll go and put my a value in here, so I don't need to rewrite all this. I get my exact a value. I hit times x. That's my numerator. Underneath I have x squared minus 4x. I tab across, I get dx, and I hit enter, and my result there is 2. Okay, so that is that's equal to 2. Now my var x, remember, is going to be my value, my integral between 1 and 3 of, now what's this? It's a by x squared over x squared minus 4x. Remember, in general, it's it's x squared fx minus the, right, so I evaluate that, and then I subtract my expected value squared, which is 2 squared, or 4. So now I need to go back in and evaluate ax squared using my calculator. Okay, so in we go, and perhaps we can go back and use that value, except I'll go in and I want ax squared this time, ax squared, and I need to evaluate that, and I subtract 4, the square of my mean, to get 0.359 as my var x, 0.359. So this is equal to 0.359 to 3 sig big. Okay, a couple of examples. I think 10J question 1 was similar to example 1, and now we can do questions from the rest of exercise 10J. So that'll be questions 2. Oh, we're going to do all questions, and it's on page 527. So I'll see you guys in class on Monday, and by that stage it'll be great if you've done 10J. Sorry, not if you've done 10J. You're about to do 10J, but you should have done 10I plus the question from the November paper that we'd left out that was relevant to the work in 10I. And so I'll see you in class, and we'll see how you're going. All right, all the best. Cheers.